Hello students, I am Dr. Sanjeev Punia. In last lecture of computer graphics, we discussed about the projection. As I told you that this is the fourth unit of computer graphics and the first part of fourth unit is 3D viewing. As we discussed earlier, in 3D viewing, there are the things that we studied, that's the introduction of 3D, then how we can represent a 3D object, then we discuss about the projection, that what is a projection, and then we discuss about the basic classifications of the projection, in which we discuss the parallel and perspective projection with their differentiation based on their characteristics. Then we discuss the orthographic and oblique projections also based on their classifications. So till now we discuss about the viewing as well as projection. So from today we will start clipping. So let's start clipping. So clipping is a process of determining that which element of a picture lies inside the window and visible. From the starting, as I am telling you, that we have to convert a word coordinate into view plane. A view plane. When I discuss about the projection, then I told you that we are dealing with a camera ready projection that is in three-dimensional, but we cannot see in three-dimensional anything on any output device as video display unit. So in that case, first of all we have to convert this 3D image, this 3D object into 2D image. And I taught you about the window to viewport and viewport to window mapping also, transformations also. There I saw you that if we have an object or we have an image like this, okay, let me draw another one. So this is a window, this is our world image, this is our world image. So if we have to see this image in this window, then we are able to see only this part. Means we are not able to see this part and this part. I am giving you one more example for this in a simple way. Suppose this is our window of a house and there are lot of things outside window, then whatever you are seeing from the window, that is the visible things. But it can be the case that you are not interested to see all the things. So in that case, we have to clip the things. Clip the things means we have to see the things only and only whatever we want, or the things those are not of our requirement, we clip the. So clipping is the process of determining. So first we have to find out that which element of the picture is for our use and that lies inside the window or not, and that should be visible. The shielding or exterior clipping. See the difference between clipping and exterior clipping. So this is also called shielding. Shielding or exterior clipping is the reverse process of clipping. So this is clipping, this is exterior clipping. Or we can say it interior clipping also. Interior clipping also, where window acts as a block used to abstract the view. When we have to block something, then we have to use the window in that case. So in case of clipping, whatever we want to see in window, we have to check the different elements of that object and that should be visible. But this exterior clipping or shielding is the reverse process where window act as a block. So this was about the clipping. There is always a one question from the clipping. So first we will try to understand that what's the need of clipping or what's the applications of clipping. When we have to extend the definite part of a screen for viewing, when we have to zoom a special part or any part of an image, then we can use the clipping. We can use the clipping. Means first of all, we have to select that part only, and then we can view it in the different window or in the bigger size. When we have to perform the different drawing operations like erase, copy or move. And in another case, when we have to display multi-view windows at the same time of the same object. Next is to create object using solid modeling techniques. Clipping is also used in anti-aliasing line segment or object boundaries. We will see this in detail in unit 3rd. Anti-aliasing and object boundaries. And last but not the least, to identify visible surfaces in 3D. Here we will discuss about the Z about the depth buffer algorithm and painter's algorithms also. So we will discuss about visible surface detection or identification techniques. So this is the basic applications of using clipping. Now we will see that what are different types of clipping or clippings, or when the clipping can be performed, or when we can perform the clipping. So clipping can be performed at three time. So at the analytical clipping, this is scissor clipping, and this is raster clipping. These depends on the time, that at what time we are using the technique. So analytical clipping is a clipping that is used before the sprint conversion. As we discuss sprint conversion in detail, means to display each and every point, every pixel on the screen. So when we have to clip before the displaying, then that is called analytical clipping. Scissoring is the process, or scissoring clipping is the clipping that is performed during scan conversion. In that case, the image parts, those are outside the window, we click them, or we do not show them on the screen. We write only regions those are inside the window, and this is called a brute force technique. Third one is raster clipping. It clips the window after the scan conversion, means when we have the complete image, and after completing the image we want to modify that image, then we can perform raster clipping. In this, we have to write or render each and everything on a temporary canvas that is outside or inside the window. That does not make any sense. It's true that it is a wasteful of things, but sometimes what happens, there may be some other time we need some other part, and some more other time we need some different part. It is raster clipping is mostly used technique, and it is simple and easy to use. So based on time, clipping can be done at three times. First, before the scan, that is called analytical clipping. Second, during the scan conversion, that is called scissoring. And third one is after scan conversion, that is called raster clipping. So type of clippings now, or the clipping that we can perform on point clipping, line clipping, the clipping that we can perform on a point or on a pixel, that is a point clipping, line clipping, polygon clipping, area clipping, text clipping, and curve clipping. Over here in this, only point clipping and line clipping are in our syllabus. So we will discuss about point clipping and line clipping. In line clipping, there is the most important algorithm, that is Cohen-Sutherland clipping algorithm. And this is the last topic of fourth unit. So first we will discuss about the point clipping first. So let's start about the point clipping. So as I told you that whatever the operations we are perform on an object or on an image, then all the operations we have to perform pixel by pixels. When we were doing the transformation also, in that case we are seeing that how we can transform one point to another location in case of different transformations like rotation and different type of transformations. And after that we combine or we repeat the same technique for all the corresponding pixels. In this is really very simple and easy to compile. In this, suppose I want to find out that a point P is outside, P is Pxy is outside or inside. So we have to check that this point is outside our window or not. This is our window. We have to check that this point, the point whatever we want to check, that is outside the window or inside the window. If point is inside the window, then there is no need to clip. But if point is outside the window, then we have to click the point. You can see here that this is point P1, point P2, point P3. This is, where is P3? Where is P3? Okay, leave it. P4, P5, P7, P8, P9, and P10. These are different points. Now we want to find out that which point we have to clip or which are the points those no need to click. So the size of the window is given over here, that WF min. WF min means on x-axis value of minimum coordinate, on x-axis value of window minimum coordinate. So this is W min. W represents window. The coordinate of window on x-axis. It represents that we are taking x-axis in consideration. W represents that we are taking window in consideration, and minimum represents that this is the minimum value of x coordinate, and this is the maximum value of x coordinate. In the same way, this is the minimum value of y coordinate, and this is the maximum value of y coordinate. We can find out or we can check that a point is inside it or a point is outside it by checking these two conditions only. Suppose point is over here, point is over here. It means on x-axis, on x-axis, it lies between wx min and wx max. When a point lies inside this region, it means it lies between wx min and wx max. And when the point lies between these two values on y-axis, it means then point lies between these two values of y-axis. So we can check that the point is inside the value, that the value, the x coordinate value of a point should be greater than wx means it should be after the coordinate, after the value of this coordinate, and less than wx max, and less than this means it should be between these two, same as it should be greater than wy min means greater than this one and less than this. You can see over here that this is and means both the conditions should be satisfied. If both are not satisfied, or we are not checking both the cases, then there can be some error or we cannot reach on the right decision. So in these cases, we have to find out, or we have to check in both the condition. So if the value of the point is inside this, or it satisfy this property, in that case there is no need to click the point, or point is inside the or within the window. And when this condition is not going to satisfied, in that case we have to click the point. You can again see from here that P5, the value of P5 is greater than Wx min, greater than Wx min, you can see over here, and less than Ws max, less than this. And keep this thing in the mind, and the value of y is greater than wy min and less than wy max. So there is no need to click P5. Now take the example of P2. In this case, the value of P2 is greater than Wx min. Wx min. So it's not necessary that when the value of x coordinate is greater than minimum, then it will be inside the window. Because when the value of x coordinate is less than wx max, then this is inside the window. But in this case, the value of x coordinate is also greater than ws max. So this is outside from the window, and if this is outside from the window, then there is no need to check the second condition. It means the point is outside, either it will be over here, over here, over here, or wherever it is. But this is outside in x coordinate. If this is outside in x coordinate, means it is not fulfilling the first condition. If it is not fulfilling the first condition, either it fulfills the second or not fulfills the second. It does not depend on that, because in case of and, both the conditions should be satisfied. So this was about the point clipping. So in the next lecture we will discuss about line clipping, and line clipping is very important topic, because in line clipping we have to study about very most important topic, that is Cohen Sutherland clipping error. But to study line clipping also we have to understand the concept of point clipping, because in that case also, in line clipping also, we have to check the coordinates of the endpoints, the coordinates of the end point of the line, and we have to perform some basic calculations on them to check that the lines are inside the window, outside the window, or partially inside or outside. So I hope that point clipping will be clear to you now, and we will discuss the line clipping in the next lecture.